Varmt välkomna till dag 3 av Uppsala International Business Week 2024. Jag heter Linus Andersson, jobbar på Almi och med regional exportsamverkan med fokus på företag som vill växa internationellt. Kommer moderera dagens samtal. Idag har vi ett superspännande tema som ligger helt rätt i tiden, känns det som. AI, en drivkraft för global konkurrenskraft. Vi kommer att få lyssna på lite olika perspektiv kring det här. Men för att sätta scenen och för att komma in i det här med AI så ska vi först få en presentation och en dragning kring vad AI är och vad det finns för olika typer av AI. Det här är också ett ämne som det finns väldigt mycket engelska begrepp i. Så att, för att underlätta så tror jag också att Edwin kommer att presentera på engelska. A warm welcome to our first speaker, Edwin Holst, AI specialist, Neurolearn.
Tack så mycket. Yes. So as Linus just said, my name is Edwin, and I work at Neurolearn as an AI engineer. The purpose of this presentation is to kind of give you all a bit of an insight into what AI is and kind of demystify it. So I will be starting about talking about what is AI and machine learning and trying to define it a bit more. And then we will be talking about neural networks and deep learning, what that is, and move on to generative AI. So first of all, when we go to a customer, we have this kind of value proposition that we talk about, and we say that these are key success factors to succeed with AI. So the first of all, you need relevant data because AI is inherently a data-driven process. And second of all, you need a lot of domain expertise, and this is where you guys come in. Like, you know your own processes really well, and hopefully, this is very important for us as a company to start understanding what you do, because we can't just solve everything with AI. We need to integrate it with your existing processes and try to improve them. And then, of course, we also need some AI expertise in order to actually implement these systems. And by doing this, we can get some value from AI. So, but this is perhaps a bit of a lot to ask you guys to be experts in AI. So instead, from this lecture, I want you to have some AI knowledge. And with this AI knowledge and your domain expertise, I really hope that you can spawn some great ideas on how to improve your business. So first of all, what is AI? So there's lots of different definitions of what AI is, and we have one here from Stanford about artificial intelligence is the science and engineering of making intelligent computer programs, or machines, especially intelligent computer programs. And I don't really like this definition, even though it's what a lot of people think about when they think about AI. They hear artificial intelligence and they kind of think, well, it's intelligent computers, right? But the definition of intelligence is very vague and it's different for everybody. So, and it's not perhaps true for most people's definition of what intelligence is. So I much more prefer this one from Microsoft that says that artificial intelligence is a technology that mimics certain human capabilities, such as understanding natural languages or recognizing pattern or learning from experience. So, and of course, AI is like, for me, as in like in academia, it's just a field of study, right? So, and it's a quite large field with lots of subcomponents. So one subcomponent is machine learning. So all AI system doesn't need to learn from experience. This is just a subfield within the large field of AI. And furthermore, we have deep learning, which is kind of buzzword, but it also just talks about the specific model type being used in these AI systems, and specifically like kind of large neural networks. Then we also have different kind of use cases for AIs. We have this generative AI, where we actually try to generate new content, such as text or images. And we also have this large field of machine vision, which kind of touches on all these different. So there's both machine vision that uses machine learning and deep learning, but it doesn't have to be. And the same for natural language processing. We have had natural language systems a long time before we started talking about the machine learning and deep learning, and that are still classified as AI. So AI doesn't necessarily have to be state-of-the-art ChatGPT and considered intelligent, right? We also have domains such as time series analysis and also like rule engines, which is not necessarily, which is just a example that isn't machine learning at all, but still considered AI. So let's talk a bit more about what is machine learning. So under the domain of machine learning is kind of computer vision. We have anomaly detection. So we also have natural language processing, a time series, and so on. And what's kind of important about machine learning, the definition is mostly that instead of explicitly programming a computer to do a task by following a set of steps, we instead make this kind of general purpose computation machine that actually adapts and changes based on giving it examples. So instead to have to reprogram your computer program every time you come to a new task, you can just build a data set of examples and it can learn by that. So some machine learning examples. The general gist of the machine learning model is that we have a model that takes an input, and we often call it X, and it takes an output that's called Y. And this X and Y can be almost anything. So here we have, for example, an image and as the input, and the output can be a classification. So for example, we can classify it as a type of animal, such as cat or dog. We can also have it classified as a more general label, such as faulty or okay. But we can do a lot more with just this model architecture. We can give it an image with a missing piece, and the output should be the completed image. Or we can give it a start of a sentence, and the model should predict the next word in the sentence. So the most used cases in computer vision are kind of, we have a few different subdomains. So we have tracking and segmentation, which is basically where we try to identify an object and keep track of the position of it. We also have image generation, which is maybe not the easiest one to find a use case for right now, but it can be very fun to play around with at least. We also have object detection and recognition, which is where you have kind of an image and you try to identify different objects that you have pre-specified and where they are in the image. Then we have some other techniques such as anomaly detection. So maybe you have a set of images of how your product should look like, and then you give it a new image and you want to see where does this differ in any part of the image, like what's the difference. You also, of course, have face detection and recognition, and you also have something called semantic segmentation. So sometimes this object detection and recognition use case is the most effective one. For example, in self-driving cars, it can be difficult to kind of define the road as an object, right? You can't really draw a block around it and say it's an object, so it might be more useful to just specify like each position in this image, what is it? So then you can see in the image there that you kind of, each pixel in the image, you give its own class. Furthermore, we have this time series analysis, and this is includes everything from video and market prediction to motion capture and speak recognition. So whenever you deal with this type of input that doesn't have a specified length, you kind of need to switch domains, and then you're looking more at time series analysis. And this is, I think, the most useful, the most general thing you do here is prediction. So maybe you are tracking a variable such as sales over time, and you want to predict how this sales over time is changing, or how it will look in 10 hours or something similar. So let's get down into a bit more details about how these systems actually work. So first of all, we have this model concept, right? We have an input and we have an output from the model. So when we train the model, I've already said we kind of used examples for this, right? But so the most regular way to train these models is that you let the model predict the y from the input. Then you have your own set of y that you know is the truth. So and then you compare this y that model predicted to the truth value that you provide. And then the model will get a signal of, well, how wrong it was. So and then it will try to use calculations to, over time, given more and more examples, kind of minimize this error. So and basically, this works very well, and it's a kind of general technique, right? But it isn't magic. So what really is a precursor for these systems to work is that the x and the y has to be connected somehow. Like if there's no connection, if the y is just something completely random and the x is something other completely random, like you would never be able to make a machine that actually guesses correct all the time. But as long as you have some correlation between the x and the y, you can kind of almost always find a good machine learning model that fits your type and can be able to learn this mapping between the x and y parameter just by having this error feedback mechanism. So, and just to give you an example, I want you to kind of pretend to be a machine learning algorithm, right? So here we have 6 images, and these are labeled. So the x value would be the image, and the y value would be the letter in the classified image. So we have A's and B's. So if you just spend some time looking at it and kind of drawing some general conclusions about what differs class A from B, right? So now I show you a new image, and the question is, which class is it? Yeah. So you had an idea? You think it should be A? Why?
Oh, it is black. More civilized, bigger nose, for example.
Okay. Yeah, so you kind of look at some of the features of the image and say like, oh, the nose is bigger and it has similar eyes and stuff to the other, which is, I mean, that's a completely correct thought, let's say train of thought. However, like, it's clear that it's very difficult to say. Like, you only have these 3 examples, these 6 examples in total, and there's a lot of ambiguity. You don't really know if it's what it could be looking for with just these few examples. So it could be a dog, and that's what you're trying to classify. But it could also be animals with light fur, or it could be based on the background color. So we don't really know. There's lots of ambiguity left in the question with just these few images. And something that's important to kind of think of is that machine learning has no inherent conceptuality. So it can't see dogs, or it doesn't know that there are eyes or noses, right? So it doesn't really look at these features. It has to it draws conclusions about, well, what's the most information that's common with those that's different from these. And I would say from the beginning, based on these 6 images, that's just that, well, in this A class, we have a lot of bright pixels, and in this B class, there's a lot of dark pixels. So it would probably classify this as B. But if we tell the model it's A and give it lots of examples of dark dogs as well, it will keep iterating and improving until it finds kind of features that truly separate these classes. But that's something to keep in mind of, that it might be obvious for us as humans, but that's mostly because we have a lot of preconceptions and different notions about how the world around us looks. So when we look at images, I think it's important to kind of remove the actual label. So don't write cat and dogs, instead of think of it as A and B, because that's all the machine kind of knows. So let's talk a bit about the deep learning and neural networks. So for example, this is a very basic building block of the neural network. And these are kind of the engines that is able to learn and adjust themselves based on this feedback loop. So what you have is you have a neuron, which is this X1 in the image, and you have lots of inputs to this neuron. So in this case, all of the inputs to this neuron is each individual pixel in the image. What happens then is that if you imagine that you are this neuron, all you have is basically a wall of inputs that says different things. So it says either 1 or a 0. And you look at this image and you have to guess. You have to give an output. And you don't know anything. So you just give a random output by looking at this image, and you're like, I feel for a 1 out today. So, and after you have done this decision, you kind of get this feedback mechanism. So it will tell you, well, your decision contributed to you being correct. So then you will be like, oh, I made a good decision. I will enforce this. So if I see the same lamps, I will kind of treat this as the same problem. I will turn on the switch again. While if you get told that, well, you actually didn't contribute to the correct decision at all, you will have to rethink the way you map. So you kind of switch up how you think about the lights on the wall as input. And this itself isn't super useful. However, what we see is that we can make lots of these different neurons, and we can also connect them to each other. So a neuron in a very deep layer can, instead of looking at the pixels, will be looking at the output from all the previous neurons. And this is a very simple kind of structure. You just have this neuron as a building block, and then you just stack them on top of each other. You can stack them horizontally or vertically, and in the end you can build these huge and large models. I mean, when we talk about the number of parameters for models such as GPT models, you talk about like billion parameters. And what these parameters are actually counting is, well, how many connections are there between outputs and inputs to these neurons. So you can build these really, really huge models, and they are incredibly efficient at being able to map almost anything to anything, as long as there is some correlation. So what is then generative AI? So it's not so much different from traditional AI. Like, we're just trying to map some input to some output. That's the general case in traditional AI. But now often, instead of focusing on a specific task you want to solve, you're instead trying to look for patterns in the data, and you want to create new data points that doesn't necessarily already exist, but some kind of fusion between the training data. And so you just try to identify these patterns and then create new instances of data that follow these similar patterns. So a fairly easy example is a large language model. The task for the internal engine of the large language model, such as GPT, is that we should predict the next word given the sentence. So if I start with "Hello, my name," we want to predict the next word, which is generally "is." So the model might guess that it is with some certain probability. And then we can, based on what we want to do, we can maybe pick the most probable word, right? So then you pick the most probable word and you append it to the previous sentence. So now you have "Hello, my name is." And then you repeat this over and over again. So all you actually do with machine learning is that you just make an engine that's really, really good at predicting the next word given some previous words. And that's kind of the basic engine, and you just repeat this over and over again, and you can create some strings. And what's kind of impressive is that we didn't really expect that this would work so well. But when we have created this larger and larger language models, well, if you think about it, it's kind of obvious. Like, if someone asks you, if you have a sentence with what is the color of the sun, and then the natural follow-up to this would be like, the sun is yellow. That would be the most common answer. So given just given training to repeating like kind of normal human words, you actually gain some kind of intelligence that can actually store information and repeat it within the weights of the neural network. This is kind of an incredible technology, but it's built on a fairly simple fundamental principle of just repeating words, but they are actually found to be very useful, in my personal opinion. So kind of using LLMs to boost your productivity is something I would really recommend people to do. The most obvious use cases is proof writing. Like if you're writing an email to a colleague or a customer or something, just ask for a second opinion, ask for it to proofwrite. It might just find some like misspelling or something like that, or it might like actually suggest, if you ask it for what's the tone of this message, and you can kind of inline your message with a tone of view. So if you ask, is this like, you can just ask it like, is this message in a neutral tone? And it will answer. And it's kind of an objective machine, so it doesn't care about your feelings, right? It just gives you the answer like, this is somewhat passive aggressive. Like, and that can be really good because it can be difficult to kind of see those things, but it's very nice to be able to keep a neutral tone towards your customer. And it's also a great writing assistant. Like, sometimes writing long emails can be kind of difficult and tedious. You just have this short piece of information you want to get out, but it's in a sort of somewhat formal writing case, so you have to blur a bunch of useless words around it to make it look pretty and appropriate. So, and it's really good at doing that as well. Then you also have this kind of fast and interactive research. So normally when you try to learn things, you can look it up in a book, or you can browse on the web and read some articles about it. But just to get your like first impression of what a field is, you can ask large language models such as GPT-4, and it will actually give you a very detailed summary of most of the topics you can talk about. Now, it doesn't always work, and it doesn't always provide the correct information, but like in general, it's like 5-second time investment, and you often get out like 70% of what you would have gone if you searched up an article and read it. So it's a really good like first step when researching new topics. And lastly, like, these models were originally built to translate texts, so that's also something that is really good at. So when you're not talking in your native language, it's sometimes difficult. So like just proofreading and translating, and it's often like if you use Google Translate, for example, one of the flaws with Google Translate is that when you use like things specific to your language, that's like kasta inte sten i glashus or something like that. There might be an equivalent in another language, but it consists of completely different words. So and ChatGPT will actually like find these representative. So it's a lot better on translating text than like previously state of the art like Google Translate. And yes, some do's and don'ts. Iterate with model, ask it follow-up questions. It's often able to improve its first output drastically. Like even sometimes just asking like, are you sure? It will give you a kind of more detailed or different answer, which is kind of interesting. The second is in GPT and most of the systems you have kind of tabs of dialogues, and don't use different dialogues and use different dialogues for different things, because when you write with this will keep your last messages into context. So if you're a human and you talk to 10 different people at the same time with different minds and ideas, you'll get kind of messy and you don't know what you talk about, and this tends to happen with these language models as well. So just keep it clean. If you're going to switch the subject, also switch the chat box interface. And of course, beware of hallucinations. It isn't always correct, so always double check your fact if it's important that you're factually correct. And if you're just searching for the latest up-to-date information, don't use ChatGPT, use Bing instead, because Bing actually Googles for you. So it kind of takes your question, it makes it to a Bing query, and then it searches on the web, and then it looks through the top answers, and it summarizes this information and picks out part that's relevant to you. So it can be a really useful tool, but in general, like GPT-4 model is much more knowledgeable and much more reasonable. So for everything else, use that. And lastly, don't chat about your company secrets. This is something that in general, OpenAI uses your chat messages to retrain the models. Now, they have a kind of strong incentive not to leak your secrets anyway, or personal information, because they don't want to be in scandals and such. So they have a lot of systems to try to mitigate this like very personal information from this chat and from the training data. Because when you search for an example, you don't want some random actual person's name to come up. But now they also have a paid mode for companies, which is like 50 kroners more every month than the regular subscription, which is, well, they say they don't use it to train the models on any of that chat history, so that might be a good option to invest in. Okay, so just to finish up, kind of where do you begin? I've talked about lots of different things and a lot of different subjects and how it works and everything. So to get you to some maybe more concrete ideas of what you can actually do, the first step is collect data. Like, even if you don't know exactly how to use it, if you collect data and then some AI engineer can come at it 2 years later and look at it, and if you tell them you have saved 2 years of data, their eyes will shine up. Like, it's the best thing ever when I come to a company and we have saved some data on this process for a couple of years. And I'm like, oh, please, can I look at it? Like, it's super exciting to already have the data, and it kind of shortens the period for doing projects like this. Because if I want to do a AI project with a customer, I first need the data. So there might be a startup time of a year just collecting data before you can get anything useful out of it. The second is kind of, I would say, the easiest thing that is kind of guaranteed to almost always work is visual inspection. If you have a person looking at a product just visually, and if they can sense if it's faulty or not, then given enough training data, an AI can do so as well. So that's a kind of low-hanging fruit that's very easy to you have a high certainty of success in this case. The second is kind of forecasting. This is very good because you don't really need so much data. You just need data about your specific thing. If it's sales, you just need to track the sales data. In the visual inspection category, sure, you can take images, but you also have to kind of know if the product was good and wrong. So the data collection is a bit more complicated because you need to save, well, was this product in this image actually correct? Or go afterwards and label it, right? So, but in the case of forecasting, you only need the data you are wanting to forecast. And lastly, try starting utilizing LLMs. If you haven't already, try to play around with them. Like, a lot of people are very skeptical with this, and you should be, but give them a shot and try to play with them because they are such a huge time saver. Yeah, that was everything for me. Thank you.
Thank you very much, Edwin. Very interesting to get this overview of AI and everything it can do and different types of AI. I think we do have time if there's one or two questions, but I have one question. You said that you recommend people to use AI. How much do you use AI in your daily work?
Well, I do a lot of programming,
Mm.
so and I'm fairly new to the business. Like I haven't been working a decade or so, so there's still lots of decisions that I have to make that isn't necessarily obvious what I should do, but I still have to make decisions, right, to come forward in the process. So almost all the time, when I do something, I ask an AI if like, is this somewhat reasonable? And if it's totally unreasonable, it's not too difficult for the AI to know this. And it's also great in like helping me to see alternative paths of doing something. And in the end, of course, it's me as a human who will evaluate these different options and select one. But just having someone to like brainstorm with is super useful.
So you need to select and pick out what is relevant from this, and what is useful. And
yeah, of course. And often, like, it's also very good at like, it often prompts you to like, by the way, don't take what I say face blank. You should keep in mind your specific use case and cater your decisions to that, because I don't have all the information.
let's see if we have any questions here. Otherwise, we will move on in the program. Okay, I think we will move on to the next subject. Thank you very much, Edwin,
Yes,
for this
thank you.
overview of AI. I think we give one more applause. Thank you.